morning, children. This is the second video in metals and non-metals. So we have done physical properties of metals and non-metals, and today we will do chemical properties of metals. Chemical properties of metals. Under these, we will learn reaction of metals with air or oxygen. Then second, reaction of metals with water. Then third, reaction of metals with dilute acids. And fourth, reaction of metals with salts of other metals. So, under chemical properties of metals, we will learn about the reaction with air or oxygen, with water, with dilute acids, and with salts of other metals. All metals react in this way. So before coming to chemical properties of metals, we should know how the different metals react with these different substances. Is the reactivity is same or it is different? Are some react with more vigor and some slowly? So for this we should know one reactivity series, and this reactivity series of metals I am writing here and will try to explain what is this reactivity series of metals. So I am writing here, this is the reactivity series . So these are the symbols of different metals: potassium, sodium, calcium, magnesium, aluminium, zinc, iron, lead and hydrogen. And below this we will write can you see this is platinum, and below this copper, mercury, gold, silver, gold and platinum. Here we have written this hydrogen also, though it is not a metal. This is the reactivity series of metals. What does it mean? This series is in decreasing order of their reactivity. That is, the metals on the top, they are most reactive, in the middle mildly reactive, and at bottom may not react at all. All of you should know that silver, gold and platinum, they are known as noble metals and they do not react with anything generally. So sodium, potassium, they are most reactive, these are mild reactive in between, and these are least reactive. So this is the reactivity series of metals in decreasing order of their reactivity. Now the thing arises, why this hydrogen is included in the metal reactivity series, though it is a non-metal. Why? Because hydrogen, all of you know, having only one electron in the shell, and it also forms cations like metals. So it is also included in this series. Now there is a question arises, how we can learn the series in the same order. The order should be same. These are the most, middle and least. So the order should be same. So there is a funny mnemonic by which we can learn this. Remember this reactivity series. I am writing this for you. This is Kedarnath का माली आलू जरा फीके पकाता है। केदारनाथ का माली आलू जरा फीके पकाता है। एंड द नेक्स्ट, क्यूट हैं आप। क्यूट हैं आप। इट मीन्स K for potassium, Na for नाथ सोडियम, कैल्शियम, मैग्नीशियम, एल्यूमिनियम, जिंक, आयरन, lead, hydrogen. This is copper, mercury, silver, gold and platinum. So you can learn by this funny mnemonic, केदारनाथ का माली आलू जरा फीके पकाता है, क्यूट हैं आप, silver, gold and platinum. So with this Hindi mnemonic you can learn the series of reactivity of metals. I think now you understand what is the reactivity series of metal, and all these metals, they react in the same manner with these different substances. That is, these they react vigorously, they react mildly, and sometimes they do not react at all. So this is the reactivity series. One thing more about this reactivity series is, as hydrogen is present in between after lead and above copper. So what does it mean? It means that all these metals above hydrogen, they can replace hydrogen from water and dilute acids. All the acids, they have hydrogen. Water is also having hydrogen, and this hydrogen can be replaced from water and acids by these metals only. The metals below the hydrogen, copper, mercury, silver, gold and platinum, they cannot replace hydrogen from dilute acids of water. It means copper does not react with water, or if we write the equation copper plus HCl, normally we can write CuCl2 plus H2. Hydrogen should evolve with dilute acids and copper chloride should form. But no, this reaction does not take place, as copper cannot replace hydrogen from acid. So this is how, which is about the reactivity series. With all these air, water, acids, these, they react vigorously, they react mildly, and they do not react at all. So now we will take all these reactions one by one. First is reaction of metals with air or oxygen. In air, we will take only oxygen. So the first is, so when metal plus oxygen, what they form? They form metal oxide. All the metals with oxygen, they form metal oxide. We will take few. Suppose K plus O2, it will form K2O. Valency of K is 1, valency of O is 2. So potassium oxide will be formed and the formula will be K2O. Likewise, sodium plus oxygen, it will form Na2O plus lot of heat. It is a very vigorous reaction. When these two compounds come in contact with air, they react vigorously. A lot of heat is produced, and this heat, even explosion can take place. So we do not react oxygen with this or water with K and Na, as it is extremely exothermic reaction. You know what is exo? Exo means out, thermic means heat. So lot of heat is given out. The reverse is endothermic. Endo means in. We have to supply heat for the reaction. Those reactions are endothermic. These reactions are exothermic, as a lot of heat is produced, and this heat, due to this excess heat, these metals, they catch fire and there may be explosion. That's why sodium and potassium, they are kept in kerosene for safety. These are sodium and potassium, or potassium, and this is kerosene oil. So they are not kept in water and they react vigorously with water. We will see now, and they react with oxygen also or air also. And if they are kept open, the humidity is present in air. With the humidity of the air and oxygen, they react vigorously. So these are kept in kerosene oil for safety or for security. So this is how these two react with oxygen, and the reaction is vigorous. Now about magnesium, aluminium, zinc and iron. So these, again, all of them, they form oxides. Aluminium oxide. Do you know the formula of aluminium oxide? Al2O3. Why? Because the valency of aluminium is 3. So we will write 3 here. Valency of oxygen is 2. So we will write 2 here. And the formula of aluminium is Al2O3. Aluminium oxide. Likewise with zinc, ZNO is formed, zinc oxide with Fe. The oxide which is formed is Fe3O4. And what is the name of this oxide? This iron oxide. Normally we can say it iron oxide, but it is iron 2,3 oxide. What does it mean? Why it is iron 2,3 oxide? What is this 2 and what is this 3? This iron oxide Fe3O4 is a mixture of two iron oxide. One is FeO and other is Fe2O3. Both together they form this Fe3O4. Iron has two valencies, variable valency. Here the valency is 2, here the valency is 3. So 2 oxygen, 2 iron, FeO will be formed. 3 iron, 2 oxygen, Fe2O3 will be formed. So this is iron 2 oxide, this is iron 3 oxide, and Fe3O4 is the oxide of, it is a mixture of these two. So we write it as iron 2,3 oxide. So iron with oxygen, it also forms iron oxide. Now copper. And iron does not form oxide without burning. Iron pieces, they do not react with oxygen. If we take iron in its filing form, do you know what are filings? Iron filings. Iron filings are small thin strips or thin pieces of iron like this. You know burada? So these are iron filings. When iron filings are put in oxygen on a burning Bunsen burner, then only this oxide is formed. Otherwise, iron does not react with oxygen. All of you know in small classes, magnesium burns with a white dazzling flame. And these are aluminium. One about copper. How copper reacts with oxygen? Copper plus O2 is 2Cu. Some of these reactions are not balanced. I am writing just like that. You balance these reactions by yourselves. These are the simple balancing. So copper with oxygen form copper oxide. How? Copper does not form oxide. If we have this copper rod and we heat this rod, then what happens? It becomes black. And this black deposition on copper rod is copper oxide. It deposited on the copper wire or copper rod, which is black in color. Now one thing more, these magnesium, aluminium, zinc, these metals, when they are put in air, slowly a dull covering is formed on the pieces of magnesium, aluminium and zinc. What is this dull covering? This dull covering is the oxides of these three, and the oxides form a protective layer on these metals, so they are not further oxidized. A protective layer of MgO, Al2O3 and ZnO is formed on the pieces of metal and they are not further oxidized. So this is how reaction of metal is with air or oxygen. This silver, gold and platinum, they do not react with air in any condition. In cold or in heat up, they do not react with oxygen. That's why we see that silver sometimes reacts to form not with oxygen but with sulfur. Silver sulfide is formed, but these two, they do not react with oxygen. So this is how reaction of metal is with air. Now second, we will go to reaction of metals with, we will use this reactivity series in all the reactions. Kedarnath ka Mali. So this is the reactivity series. Now the reaction of metals with water. The second is reactions of metal with water. So again, metal plus water. What is formed? When metals react with water, their hydroxide may be formed or their oxides may be formed. When metal react with water, hydroxides or oxides may be formed. First we will take potassium and sodium. So potassium plus water. What is formed? Potassium hydroxide is formed. This is formula of potassium hydroxide. When sodium reacts with water, sodium hydroxide is formed. Plus lot of heat, and this is a very vigorous fire and they also start burning. So fire is caused when these two, they react with water. That's why they are not kept in water, they are kept in kerosene oil for safety. So when they react with water, sodium hydroxide is formed, potassium hydroxide is formed, and hydrogen is formed, and lot of heat is formed. Now next, these two and magnesium also. Magnesium reacts with hot water. It reacts with hot water and magnesium hydroxide is formed and hydrogen is formed. This is magnesium hydroxide MgOH whole twice. So magnesium does not react with cold water, and these two, they react even with cold water. And it reacts with hot water and magnesium hydroxide is formed, and no burning, no fire is there, as this reaction is not much vigorous. It is a fast reaction, but it is not vigorous. But if this magnesium, it is reacted with steam, then instead of MgOH whole twice, magnesium oxide is formed and hydrogen is evolved. So with steam, magnesium gives oxide. With hot water, it gives magnesium hydroxide. Now what about aluminium, zinc, iron? All give only oxides and not hydroxide. So aluminium give Al2O3 plus hydrogen, ZnO plus hydrogen, Fe3O4 plus hydrogen. So you write these equations by yourselves. So these two very vigorous and form hydroxide. This also form hydroxide, and these form only oxides. And up to here only the reaction of water takes place. After lead, no reaction of water takes place. Lead and all these, they do not react with water. This aluminium, zinc and iron, they react in steam form. We can write here also aluminium plus water, which is steam. It forms Al2O3 plus H2. Likewise, Zn plus water, also steam, ZnO plus hydrogen. Then iron plus water, also steam, and Fe3O4 plus water. So these three, they react when the water is in steam form. This can react with steam as well as hot water, and these react even with cold water. So this is the reaction of different metals, and after lead they do not react at all. So this is the reaction of different metals with water. Now you must be knowing that this and this is alkali, very strong bases or alkali, and they are also formed when K2O, it dissolves in water. These alkalis are also formed when these K2O or Na2. These are the oxides. When they dissolve in water, they also form KOH and NaOH. This means these oxides of sodium and potassium, they can dissolve in water, they are soluble in water, and they form strong alkali KOH and NaOH. All other, they are not soluble in water. Calcium hydroxide is slightly soluble, but they are not soluble in water. All of you know that the metal oxides, all the metal oxides, they are basic in nature. They behave like bases. It means they turn red litmus blue. That is, they react like bases. And all the non-metal oxides, they behave like acids. They are acidic oxides and they turn blue litmus red. So, are all the oxides are basic? Yes, they are basic, but these two, aluminium and zinc, they are basic as well as they can react as well as acidic. It means aluminium oxide and zinc oxide, they both can react with acid as well as base. So a special name is given to them and they are known as amphoteric oxide. Ampho means dual, two. So these are known as amphoteric oxide. So I will write the equation for these, for Al2O3, for ZNO and amphoteric oxides. Amphoteric oxides. All metals will not form amphoteric, only aluminium and zinc, they form amphoteric oxide. Very important, asked in exam many a times. So you should know the formation of these oxides with water or with oxygen and how they behave with acids and bases. So you balance the equation by yourselves. I am writing first with aluminium oxide. Al2O3 plus HCl. What will be formed? Aluminium chloride. Why 3 here with chlorine? Because aluminium has a valency of 3, chlorine has a valency of 1. So AlCl3 and hydrogen gas is evolved. So what water is formed, not hydrogen, water is formed. So this is the reaction of Al2O3 with acid, dilute acid. So when they are reacted with dilute acid, chloride of the metal is formed. Now this Al2O3 can also react with a base. NaOH is an alkali, a base. What will form? NaAlO2. So this is a different type of compound. You can see here, this is also metal, this is also metal, but this aluminium metal, it is present as anion. AlO2 is an anion, sodium is cation, it is a base and the name is sodium aluminate. So the name of this compound is sodium aluminate. Here aluminium is present as anion with oxygen. AlO2 is an radical or anion, sodium is cation. So this is a special salt which is formed by this oxide with base. So these two, they are special. They can combine with acid as well as base. Water is formed. You have to learn the formula NaAlO2, sodium aluminate. So I can write with zinc also. Zinc with dilute HCl, it will form ZnCl2 plus H2O. Zinc chloride. You balance the equations by yourselves. Now this is with HCl. Now this oxide can also react with base or alkali. What will be formed? Na2 ZnO2. The formula is different here. It is only Na. Here Na2ZnO2 plus H2O. And the name of this compound is sodium aluminate. So this is sodium zincate. So the name of this compound is sodium zincate. That is aluminate and it is sodium zincate. Here zinc, this zincate is present as anion and sodium as cation. So these two, they are special salts formed by aluminium oxide and zinc oxide when they react with NaOH or strong alkali. This is how these oxides are amphoteric in nature, means they can combine with both acid and base. Other are basic in nature. One or two compounds, two oxides of metal, they are also acidic, but that is not in your syllabus. They are of manganese and chromium. So we leave them, and this is now the next is reaction of metals with dilute acid. The third is reaction of metals with dilute acid. So simple reaction is there. These two, their chlorides are formed and hydrogen gas is evolved. So almost all, they can react with dilute HCl or dilute sulfuric acid. These metal can react with dilute HCl and dilute sulfuric acid, and their chlorides are formed. We start from magnesium. Magnesium plus dilute HCl, it forms MgCl2 plus hydrogen is evolved. Or aluminium plus dilute HCl, AlCl3 plus hydrogen. Zinc with dilute HCl, ZnCl2 plus hydrogen. So in all the cases, hydrogen is evolved and chloride is formed. What happens? I have not taken here the third acid, nitric acid. Nitric acid is also a mineral acid, HNO3. I have taken only chloride, this hydrochloric and sulfuric. The same reactions are with sulfuric acid, MgSO4, Al2SO4 whole thrice and ZnSO4 whole twice. So, ZnSO4. So, sulfates will be formed, here chlorides are formed. But we have not taken HNO3 in this reaction with metals. Why HNO3 is not taken? Because HNO3 is a very strong oxidizing agent. What is oxidizing agent? Oxidizing agent gives oxygen for the reaction. It supplies oxygen for the reaction. If HNO3 is taken, so it will supply oxygen, and instead of hydrogen, water will be formed. It oxidizes this hydrogen into water and reacts with water to form other its nitrates like NO2, NO or N2O. Nitrate of nitrogen oxides are formed, and this hydrogen it converts into water due to the presence of this HNO3, which is a strong oxidizing agent. So no metal reacts with HNO3 and produce hydrogen. They can react, hydrogen can be produced, but it converts to water. Only two metals, one is magnesium and the other is manganese. You know, manganese. So these two metals can react with nitric acid when the nitric acid is very dilute. Very dilute. That's it, about 1%. Very less acid and more water is there. If the nitric acid is very dilute, then these two, magnesium and manganese, they can react with HNO3 and hydrogen gas is evolved. And all of you know that below hydrogen, no metal can react with acid, any acid, because they cannot replace hydrogen from acids. So this is how the reactions with air or oxygen, water and acids is taken, and in the next video we will take the reaction of metals with other salts, salts of other metals. So this is all for today. Thank you.